线上研讨会。那希望今天1个多小时的时间，可以让各位有一个丰富的一个收获，来了解这个绿色夹爪的一个最新科技。那简单说，为什么叫绿色夹爪？就是说它这个夹爪基本上不需要额外的能源，它是利用一种这个 biotech， 就是这个生物的这个一个科技啊，基本上来满足这个制造业上面的一个夹取的一个应用的需求，所以我们称作为这个绿色的科技这样。那现在我非常高兴邀请到这个 INNOCISE 的这个创办人 Dr. Mark Shuai 来做这个开场白的一个公司的跟这个科技的一个背景介绍。Dr. Mark Shuai, please introduce to our client our valuable guesses about the INNOCISE and vision of the company. Please.
All right, thank you very much. So yeah, I'm really happy to be here and thank you for the invitation. What I can do is make some breaks. If you want to make a translation directly, it is up to you, Barry, how you want to proceed.
Sure. Please go ahead, and then I will do the simply translate to our client.
I'll make some breaks.
Yes.
Perfect. So yeah, I'm really happy to be here. So good afternoon to Taiwan. Good morning from the very cold Germany. So we have -5 degrees here. I know that the weather is normally better in Taiwan. Mm-hmm. So I'm really happy to be here today. And my name is Mark Schöneich. I'm the founder and CEO of INNOCISE, which is a high-tech company in the automatization environment. Yeah, I want to give you just a few words and a short introduction about our technology.
Okay. Dr. Mark Shuai 是这个 INNOCISE 的公司的这个创办人，所以他今天非常高兴这个来到这样的一个线上的活动，来给大家做一个公司的一个详细的介绍跟说明。好，那现在这个德国的温度大概应该是-5度，哦，所以今天利用这样的一个时间，就是第一次在台湾举办这样的活动，所以他个人非常开心，跟这个希望跟大家做一个这个很好的一个交流。所以大家如果会后有问题的话，可以随时提出来。Doctor?
So today, of course, we want to speak about gripping without energy, green gripping. So what is INNOCISE doing? We will see later on a detailed introduction by Yolanda Stabel, who's the expert in this field. But to give you a short idea what we are doing. So if you have a robot, for example, and we want to manipulate something, for example, a smartphone. So we have a robotic system, we have an arm, we have an end of arm tool, which is, for example, a gripper. What INNOCISE is doing is the fingertip of the robot. So we develop new fingertips of the robot, so the last millimeters from the robot to the part in order to grip without energy. So we are experts in material science and in microstructuring to create adhesion based on the gecko effect coming out of nature.
Thank you, Doctor. 稍后的细节会由这个另外一位专家Yolanda来跟各位做一个这个新技术的这个一个细部的一个说明。那这个 Doctor 给我们的这个讯息是说，基本上这个新的技术啊，基本上就是来做一个取放的一个应用。那其实它的原理基本上就像这个各位生活中一定看过的这个壁虎的这个的这个小的生物啊，基本上它的奥妙就在它的一个爪上面。那他们利用这样一个仿生的技术啊，把它开发出来，那应用在这个实际的这个比如说结合手臂啊，来做这个物件的取放。那目前就我们所知，基本上这个物件呢，基本上其实不限什么样的材质。哦 ，OK， Doctor。
Thank you. So you could say right now coming from Germany to Taiwan is a long way, but sustainability, gripping without energy, reducing costs in the production line by ruling out compressed air and expensive tubes is a topic which is really important for every one of us. And we know the Taiwanese market very well because I was in Taiwan 2 times in the last month. So this is really important for us to enter important markets like the Taiwanese market.
OK， 他的提到基本上这样的一个新的科技带来的效益，就是说基本上你不需要额外人员，那也意味着说，譬如说我们在做这个手臂取放或是不同的这种设备的取放的时候，基本上你的相关的管路基本上这个也会变成被移除掉了，所以这当中节省下来的这个效益，基本上是这个科技可以所带来非常一个巨大的影响。那 Dr. 本身他其实在过往也来过台湾，所以也非常了解台湾是一个极具潜力的一个市场哦，在他们的一个了解当中，这样 ，Dr.
So Taiwanese market, of course, is really interesting for us, and but of course we are a quite young and innovative high-tech company in Germany, so it is complicated for us to go to the Taiwanese market. So we have partners, of course, partnerships and friends like today. So we are able to speak to all of you here and discuss. We have as well a partnership with Shank in terms of gripping and clamping solutions in Taiwan. So we have a Taiwanese team constituted of about 6 to 10 people who are as well based in Taiwan. So we are able to act quite fast. And as you see right now today in of course, not only English, so in your local language as well, which is really important. Another really important point for us to speak to you today, and we are really happy to present our technology to you, is the market where we are working in. So we are especially working in optics, in electronics, in display. So display coming from the coating environment. So like you see behind me, screens. But going down to the small applications, which Yolanda will explain you later on, for example, for micro LED environments, so new display generations, but as well semiconductor applications. Semiconductor applications going from, of course, UV lithography processes up to wafer handling environments, and once again, really small handling applications. Sorry, this would be complicated for translation, but try your best.
No problem, no problem.
Okay, great.
Sure. 当时说，基本上这样的科技，基本上在他们的点来看的话，基本上可以用在非常多的一个工业应用上面啊，产业应用，像是这个display， 然后 electronic。这个电子，那另外像这个台湾非常有名的这个 high tech semiconductor 半导体的部分，基本上都是他们现在同步在发展进行中，利用这样的一个新科技来取代现有的一个取放的方案。当然他们INNOCISE基本上是一个非常年轻跟有创造力的公司，所以他们今天就借用这样机会跟这个台湾的伙伴 JYTC 这边来进行这样的一个线上的一个研讨会，也希望把这样的一个新的技术、新的应用带给这个台湾的客户。Dr.
So what I want to say is that we, of course, know already a little bit the Taiwanese market. We are available to visit you, to see you in person. We have our team set up already there, so that you have an impression that we are already there and we can help you guys. What is really important today is not that I'm speaking a lot, because I just want to be here and tell you that for us, sustainability is really important in gripping. It is really important that we move on towards new technologies, towards high-tech applications in the production environment, coming from manual work, so manual labor, to automated environments where we have robots, doing the work and enabling the workers to do better and more intelligent work. And this is really important for us, and that's why it is necessary that, and I'm really happy that Yolanda as an expert is here today, Kati of course as well, joining our team, and to explain you more into detail what we can do and to help you understand probably where we can connect INNOCISE, of course, YITC, and your ideas for an application for tomorrow. I'm once again very, very happy that you guys are here today, and we are always open for your questions. I think Yolanda will answer your questions later on, and you can always, of course, reach out to me as well on LinkedIn or via our team. And I will not speak more today because you need your time for your questions and for your technology. I'm once again very, very happy that we have the possibility to speak together and meet. I will be able to spend a little bit 5 to 10 minutes again and into this meeting stage. I need to leave then. But once again, thank you as well for the organization. And I'm looking forward to see you again, probably in person in Taiwan. Thank you very much.
好的，这个 Data 非常热情哦，所以他非常希望这个很快的有机会跟大家在这个台湾碰面，面对面的这样去做交流哦。因为他们知道基本上这个绿色的科技啊，基本上在我们现在的社会啊，在这个地球上面基本上是非常重要的一个议题。那可持续性 sustainable 这个可持续性的议题，像 ESG 啦，怎么减缓这个环境的冲击啊等等的，基本上是这个每一个企业基本上都必须面临到的一个问题。所以他个人非常希望这个来到台湾，基本上跟大家有所进一步的交流。如果说会后基本上各位有任何的问题，或是说个人需求，请这个随时可以跟我们联络，然后基本上我们进一步的协助来做这个评估跟这个了解怎么去提升客户这边的一个需求跟这个怎么来达到更好的一个能源的上面的一个有效运用。Okay, thank you very much.
Thank you
for your speech, and we wish you all the best in the new year together with the JYTC, and then we open up the new market, new opportunity together. Okay.
Thank you very much.
Thank you. 好的，那现在时间Dr. 他需要先离开，所以现在时间我们就交给另外一位 expert 这个 Yolanda 来帮我们很仔细的一个介绍这个新的绿色科技。Yolanda, free?
Yes. So you should see the presentation slides then again. Yes.
Yes.
Okay, yes. So as Mark Schöneich mentioned at the beginning, our technology is inspired by the Gecko. So we are a spin-off from the Leibniz Institute for New Materials, and there they spent a lot time to watch at the Gecko. So to use the chat, because we have the possibility, I ask now one open question. Do you have an idea what kind of forces do the Gecko use to stick on every surface? So if you have an idea or something, you can write it in the chat. I will now explain how the technology works, and then at the end I will say what kind of forces, what kind of interaction the Gecko uses. But to have a bit interaction in the team, feel free to also guess, if you don't know it, what kind of force, what's the name of the force the Gecko uses to stick everywhere. So here on the picture you see that a Gecko sticking on a glass surface, and you see he only has a few contact points, and only with this small contact points he's able to hold his whole body weight, which is, compared to the surface he uses, really high. So at the Leibniz Institute of New Materials, we researched a lot this effect. How can the gecko stick everywhere, even if the surface is very plain or if it's rough? He simply need to touch it and then he can stick without that you need to put an electric cable on it or a compressed air. So after a lot of research, we tried to copy this technology for industrial gripper. So you can see here one of the first prototypes of the gripper. So you have, of course, some metal parts, and then the gripping part of our gripper is always a microstructured polymer. Here you see it in white. So everything which is here in white is the microstructure. And then you can see some hairs. It's not that easy to see, but all the white foam, this is the structured microstructure. And then I will show it here a bit closer. So if this is what you saw here in this picture in white is shown here in blue, so you have a backing layer of the gripper, and then you have a lot of tiny fibrils, and they are very, very small. And this is the way how we achieve to generate forces, because the fibers are that small, we come that close to the molecules of the object we want to handle that the molecules will interact together. They will interfere together, and only due to this molecular interaction we can create adhesion force. So this is why the gecko can simply touch a surface and then he can stick there for hours and days and weeks if you want. But then, of course, the gecko wants to move again. And now if we're thinking about the gripper, so of course we simply need to touch the object to be able to lift this object up. But then, of course, at one point we want to place the object. And therefore, there are, for the placing, there are different mechanisms. The goal is always to reduce the contact area between the fibrils of my gripper, so here the blue fibrils, and the object surface, which is here shown in gray. Okay, so now I let translate you.
OK， 有人利用这张简报来跟大家说明，最左边这个是一只壁虎，那基本上它用非常小的接触面积将它的这个身体的重量吸附在这个玻璃上面，所以各位看到基本上它跟玻璃之间只有接触非常小的面积。那从这个壁虎右边这张图，基本上各位可以看到，基本上它其实如果在显微镜上看到的话，基本上它会是非常多的细的毛这个角基本上是贴在这个玻璃上面。那当然他刚才有问到这个壁虎是用怎么样的一个 force 这个力去将它自己这么相对比例的一个重量吸附在这个比如说墙壁上、玻璃上这样子。基本上是在我们这个邀请函上面基本上有提到一个叫凡德瓦力Van der Waals 的这个一个原理基本上让它自己可以吸附在不同的表面上面。那左边数过来第3张图，这个基本上就是呈现这个细的毛角跟表面基本上各位可以稍微仔细看一下，基本上这个细的角跟毛跟这个物体中间有点像是这个正电跟负电基本上会吸引在一起之后，基本上产生这个凡德瓦力的这个力之后，我们就可以把这个东西给吸附起来。那接着问题是说，我们看第4张图这个 place 这个部分，当你可以吸起来之后，也得把它 place 就是释放掉。所以各位可以看到，基本上当这个角就本来是直的，我把它吸起来之后，变成弯了之后它就可以做释放的动作。那弯呢，基本上简单的原理就是说，它减少它的接触面积之后，基本上这个物件就可以被释放掉。有人的
Perfect. Thank you very much. Yes, exactly. So I think, Barry, you mentioned it already in Chinese. So the forces the Gecko uses and we are using are called the van der Waals forces. So these are only molecular attraction forces, only physical forces. So our gripper doesn't work with compressed air. It's not a suction cup. It's not working with glue or something. So it's really working thanks to the molecular interaction between the moleculars. So yes, thanks to the van der Waals forces. So we call it a dry adhesion. You want to translate it quickly or is it okay?
Yep. I translate a little bit.
Okay,
所以基本上这个INNOCISE 的科技基本上新的技术基本上它不需要，就像刚才有人达特别说明，基本上它不需要这个气压源、真空源甚至电力哦。所以基本上各位看到整个今天的简报基本上不需要任何的气源。另外它也不是利用这一种服务，就是说这种胶水什么去做粘贴，然后基本上把东西取起来，它也不用。所以之前客户也有询问到说，就会不会残留？基本上这个答案是不会有任何残留，因为它不需要胶水这样的一个东西。OK， 有人呢
？Thank you. Okay, yes. So as I mentioned, to be able to pick an object up, you simply need to get in contact with your object. So here on the picture, you can see the gripper on the top, and then you see some fibrils, like you can see it in white or something, and then you see a small SMD part. So for holding the object, we simply need to get in contact with the small fibrils and the object surface. So, and then, as I mentioned, for the placing, the goal is always to reduce the contact area between the fibrils and the surface of my object. So there are different possibilities. One is called debuckling. This means that we go further down into the Z direction, and due to this, the pillar will bend, and therefore we will have a reduction of the surface area. This is the best release mechanism if you want to be the precise as it's possible. Then, of course, if your demands on precision aren't that high, you can also remove the gripper via sliding. So you just simply shear the gripper off, or by rotating, so by turning the gripper, and due to this, the pillar will twist and then lose the contact.
OK， 第二页的一个简报说明，我们从上面看，基本上是kick 取的部分，所以借由这样的一个凡德瓦利的一个理论，基本上它的互动啊，基本上各位可以看到一个数据，基本上每平方公分啊，最大的这个技术啊，基本上可以举起1公斤的重量哦，所以这个非常的这个厉害的一个技术了哦，所以基本上从小的东西 micro millimeter 到 millimeter， 基本上这个技术都是可以应用的范围。那至于怎么放，就是 place 释放的部分，各位可以看到下面这3张图，所以基本上你可以直接在 Z 轴这个比如说手臂直接 Z 轴往下压，这个细细的角啊一弯折之后就减少接触面积，就可以做释放，或者说其他的2种方式 sliding 就从这个侧移减少接触面积，另外旋转哦，所以基本上透过这样不同的一个释放方式，可以去符合这个不同的应用场景。有人呢？
Thank you very much. Yes, so you may have seen here on the slide that there's written 1 kilogram per square centimeter. So the technology, the Gecko-Mer technology we developed, is usable for every scale. Of course, we are focusing today on the meeting more on the microscopic scale, but in general, we can handle every object size with this, starting from big glass components like for windows or something, until the smallest micro LEDs that exist for now. So the technology is available on every scale. And of course, depending on the size of the objects and on my process, I have different requirements on the adhesion force of my gripper. And we can change this by the amount of fibrils on the gripper. So the larger the surface of the gripper is, we create, the higher are the forces we can generate.
OK， 所以有人打这边补充，基本上这个力啊，目前就像各位看到简报上面的数据啊，每平方公分可以达1公斤的这样的一个力量，所以基本上就是说这个这样的一个绿色科技基本上可以适用从非常小的物件到非常大的一个物件，这样的一个范围基本上都是可以去对应。当然他们基本上有提供这定制化、客制化的服务来针对不同，因为不一定每一个产品都是完全平面，可能会有一些高高低低、曲面等等这样。那他们是可以做不同客制化程度的来对应客户的一个取放上的一个需求。Yolanda?
Thank you. Yes, so there are different possibilities to use the technology. Of course, it's also possible to use it manually for manual processes. But of course, if we are talking about high precision demands and also industrial production, of course, we are more in the automated handling, which can be done with robots. For example, the Mecha 500, which we use a lot because he's very precise. And of course, if your demands on precision are very high, of course, you need a gripper, which can be very precise, but of course, you definitely need also a machine or a robot that is that accurate and has that precision. So yes, the gripper we create is always a microstructure applied on a substrate. Here, for example, you see it on the microhandling. Usually, we have a stainless steel pin. You can see here or here on this manual gripper. Oh, sorry, that was too fast. And then here on the top on the gripper or down, depending on how you see, is the microstructure which is applied. Barry?
有人达这边特别说明，基本上在这个系统整合方面，绿色夹爪基本上可以搭配，比如说是手持作业到这个机械手臂的这样的一个自动化应用，基本上整个应用的范围跟弹性基本上是非常广泛，跟这个整合性非常高，所以在他们的这个德国那边，基本上比如说像左边的这一张图啊，这个是加拿大的一个微型手臂，Make Up 500。基本上他们目前做到的案子，基本上非常多的案子是应用这样的一个微型手臂因为它的精准度基本上是 0.5 条的一个非常超高的一个精准度。那搭配他们这样的一个绿色科技非常小的一个这个绿色夹爪，基本上来做这个不同像这种光学产品的一个取放这是目前在很多领域上面有应用上的一个地方这样。那当然这样的科技它们也可以去取代传统人员在取放一些精密零组件啊等等的上面一个使用。Yolanda?
Thank you very much. Yes, okay, so I will quickly show a video where you can see the picking of 3 different object sizes with the one same gripper geometry. So you see now we need definitely a camera. So here you see the gripper and an SMD part in the scale of millimeters. So this gripper has 3 fibrils, and you saw we simply need to touch the object to get in contact. And now here you will see the buckling. So we simply went down into Z. Yes, here we see a part which is 10 times smaller, and we can take it with the same gripper and also with the same mechanism, simply touch it, and then for the releasing, compress the gripper a bit. But of course, we can take also different shapes, like here a more complex shape of a diamond. Also here we use the same gripper, same mechanisms.
Okay. 这段影片告诉我们，基本上主要内容是在用同一个夹爪，基本上这个夹取不同的3个不同的物品。可以看到，基本上这个 SMB 的元件这个10倍大小的差异，基本上用同一个这个绿色夹爪，这绿色基本上只有3只脚 所以当它接触之后，把它取放到，所以基本上可以针对同一个夹爪，可以针对不同的一个工件大小上面一个使用，在这个影片上做一个完整的一个展示。那当它在释放的时候，它用刚才第一种讲的方式 buckling 的方式，直接 Z 轴往下压，让这个脚弯曲之后啊，就达到一个释放的一个效果。Yolanda?
Yeah, perfect. Thank you very much. Yes. So here now one slide about the macroscopic handling, what is possible. So then, of course, in the video before, you saw a gripper which has only 3 pillars. So I will just quickly show it to you. Sorry. So if this is my gripper here, you only have a microstructure with 3 pins. And in the macroscopic way, of course, we have completely fully structured surfaces because the forces we need are much higher because the objects are bigger and the weight is higher. So here you can see a picture of the Mecha 500 handling a lab tray with 2 cubes, I forgot the word. And here you can see the handling of lens. Of course, as Dr. Mark Schöneich mentioned, we are also very active in the field of optics because, of course, there the demands of a residue-free handling are very high. And because we are using only the physical forces of the molecules, we can enable a residue-free handling, which is, of course, mainly in the fields of optics and photonics industry, very interesting. So here I can show you a video where we will handle a wafer compared to other technologies of today. Maybe Barry, I just let you translate now and then I will show the video, just that the audience know what they will see now.
Okay, thank you, Yolanda. 这张 slide 告诉我们，基本上各位可以看到几张图，基本上像左边第一张，这个绿色夹爪举起这个2个小的这个瓶子啊，跟一个底座啊，基本上就像我们刚才说的，基本上它可以每平方公分的一个吸取力啊，基本上有达到1公斤，所以基本上东西的大小就没有问题，可以来做一个对应。第二个是这个 INNOCISE 这边，像刚才 Dr. 在最早有提到，基本上他们现在在 optical 这个光学的领域啊，基本上有收到非常多的一个客户的需求。那最右边基本上就是一个这个，我想各位应该知道，基本上 wafer 就是半导体的部分 ，semicon 的部分，所以待会Yolanda可以播放一段影片给各位做个比较。基本上这个很多客户在面对这样一个新科技，第一个问题就是说这个夹爪会不会产生残留？那像我们稍早说明的，基本上这个是不会有任何残留，因为它不需要胶水输入这样的一个东西在做这个吸取的一个动作。Yolanda?
Yeah, perfect. Thank you. So here on the left, you will see the application made with a gripper made by us with our technology. So you can see here the black fork, and we have 4 points where we applied our microstructure. Here in the other case, you will see on the right side, you will see one time the application with friction pads, so with an alternative to our technology, and